Hi guys. So originally I recorded this video as a 6th development log for Windward. However, it got way too technical way too quickly and I decided to scrap that idea. However, as far as technical videos goes, it's actually fairly informative. And I figure other people, other developers, might find it fairly useful. Now in this video I'm going to talk about serialization and what different approaches I went with when trying to come up with serialization for Windward, especially when it comes to sending the least amount of data over remote function calls. So if you're interested in stuff like that, keep watching and you will find it informative. So here I have a player item class, which by itself is simply marked as serializable, so it can be serialized. And it contains 3 strings, one for name, one for the type of the item, and for the icon, which is currently not used. I also have a pair of lists. One list, which is just a generic list, is a list of stats, which is something you see up here. That's the struct for the stat. It has a name inside and it has a value. Very simple. I also have the scripts, which is just another list of strings containing the names of scripts that I want to attach to an object when this item is equipped. If you are a little familiar with serialization in C#, then you probably know that adding serializable to any class will pretty much make everything inside of it serializable using the binary formatter. Or, if you're not familiar with binary formatter but you happen to be familiar with Unity, it works exactly the same way. If you happen to have serializable on top of any custom class, this class will be serialized by Unity and you will be able to see it in Inspector. But in this case I'm not relying on Unity and I'm not using the Inspector. I'm just trying to save this class to a disk. Now the reason I'm trying to save this to a disk is because later on I want to save all of this data and transfer it across the network to other players. So when players happen to have custom items, I want other players to be able to retrieve the same exact items. So when a player dies, for example, when the ship is sunk, it has a chance of dropping a similar item for another player. It's just an example. Point is, I want all this data serializable across the network, and to do this I need to save this to a stream of some sort. So that's the task. And as I mentioned earlier, adding serializable to any class is technically enough to serialize it. But is it really efficient? What actually gets saved in a file? I was curious and I wanted to find out. Here I have a simple test script that just creates an item with 2 stats, and I just want to save this. I want to save this in a file and see how big the data is going to be, because ultimately when you're transferring things across the network or you're trying to save them in files, the less space you use the better, especially if you're doing this frequently across and sending data as packets to other players. So anyhow, in this particular test I just take a binary formatter and I use it to serialize this item into the file stream. That's it. Then I close the file, then I open it again, and then I just read it back into the new item. That's it. Well, this is what it looks like when I happen to serialize it into a file. Yeah. In case it's not clear, there are 714 bytes here just to save these 5 values. 3 strings and 2 integers. 714 bytes. Now in a way it actually makes sense, because if you look close at what is actually saved, it is saving the name of the assembly where this data resides, the name of the class containing the data, the name of each field within the class, and then it goes into like system collections generic list, which is the type of the list, the player item stat, which is the name of the class, inside that list, and then additional information like version of the assembly and so on and so forth. All this information is completely useless if you happen to have only one assembly. And in most cases, when you're working with Unity, that is pretty much the case. So of course I figured there's a way to optimize this. There has to be. And started doing my due research. So the first thing I actually looked into was a way to trim the data inside. I figured out, hey, if there's such a long name associated with system collections generic list, then wouldn't it make sense to actually use my own list instead, which has a shorter name? Well, let's do just that. I'm gonna uncomment using TNet and comment out using system collection generic. And since in TNet I happen to have a class called list with all the same properties, I can just simply go back to Unity and it will compile with a different list. Now if I happen to run play, everything still works here, and if I bring in the new file, it will be, let's see, started with 714, now it is down to 644. I just saved 10% right there. And yet all I did is just change it to use a shorter name. That's it. So how else can I optimize it? Well, if you happen to derive your class from iSerializable interface, there's a way to shorten the amount of data you save. Now you can do that by overriding the getObjectData as well as creating a constructor for your class. Now getObjectData is what gets called by the serialization system if you happen to have it implemented. And in there you can actually specify which values get saved and what their names are, which is actually really convenient if you think about it. If you later on decide to change the structure of your class, say for example you were to change this to be something like item name instead, normally if you don't have that function, you will not be able to serialize older classes anymore because the name will not match. However, if you happen to have this function, this is what it would go by, this tag right here. So it will still be possible to load other older files, even if this one is called something else, like name123 for example. It will still work. Another nice thing about implementing an explicit function like this is you can actually be selective about what you serialize. In this case, for example, I have stats that I will not even serialize unless I really want to. Same thing with the scripts. So here I record a count and then I actually go through every single item and serialize it one at a time rather than serializing it as an entire list, which saves me the need to save out the list's definition, that being systems collections generic, or like in the last version, TNet list. It also means that I don't have to do stuff like this, like system string, score, and so on and so forth. This can simply be trimmed away. So let's see what happens when I actually try to serialize it like that using iSerializable. Tap back to Unity, let it compile, hit play. Everything still works here, everything gets printed, and the file is much shorter. Look at that, it is down to 186 bytes. So we went from 714 down to 186. Now we're actually getting somewhere. Of course, the downside of this approach, well, there are two downsides really, but first one is that you actually have to specify these custom functions for saving and for loading. Another downside is that this particular way of serializing happens to be one-dimensional. Like if you look closer, you will notice that I have to do things like this. for every single item, I do sn plus I being the index of the item, and the same thing with the value. That's because I cannot say add a child to the serialization info and then serialize that independently. Unfortunately, it all has to be a part of the serialization info, which is kind of ugly, but hey, from 700 whatever kilobytes down to 186, still quite effective. Of course, with me being a perfectionist, it's not effective enough. And so we are on to the second method of serialization. This is just using a simple binary stream. I wrote two functions, serialize and deserialize. Serialize takes a binary writer and just writes all of the class's data into it consecutively. Very simple stuff. Deserialize does the exact opposite. It reads the data in the same exact order that I saved it as. Now the obvious downside of this approach is the data structure is completely rigid. I cannot change the order in which the data was stored. Now of course I can do things like versioning inside here and do things like writer, write, and then specify some kind of an integer like 1, for example, indicating that this is version 1 of my data, and later on I can change the data, see is it version 1, then I do one kind of reading, if it's version 2 I do something else. I can do that of course, but it will obviously complicate the logic. Regardless, this is the most efficient way of serializing things, as you probably may have guessed already. So here I have the second way of doing things, which is just saving it to a file using a binary stream. Now if I tab back to Unity, let it compile, and hit play again, it still works, all the data gets serialized, and now the file is down to only 39 bytes. Now that is actually quite nice. So if you happen to know exactly the kind of data you're expecting and the exact order that the data is going to be in, just simply go with the binary serialization. You'll save yourself a lot of bandwidth. Now for the most part, this is exactly what I've been doing in all my previous games as well, including Windward from a year and a half ago. Now there is a downside to this method that I've ran into that I haven't covered yet, and it's the fact that this is very difficult to modify. I cannot just start modifying this file and expect it to work. It's not gonna fly. Likewise, I don't actually see any values here, like what does this STX or BS mean? I don't know. Like I don't see where the actual values, where the strength of 10, stamina of 5 is. So I have the strength value here, but where's the 10? Is this BL 10? Probably is, but I don't actually know this. I cannot see it just by looking at the file. Now you might not think that this is actually a problem, but it is. In a couple of times in Windward's development and further down the line, when people were playing the game, I've ran into issues in the game itself that involved editing saved files. Of course, when it looked like this, I couldn't edit anything. I couldn't see what was going on, and I couldn't do much. Now, it would be nice if it was possible to save this kind of information in a text format that would be readable and editable by any human. And so we're on to the next method of serialization. This one is using a custom tree-like node structure that I've recently created called data node. Now by itself, data node is just a hierarchical structure that can contain other data nodes. So think of it as an XML tree, basically. Now inside the serialization function, I get the data node to work with, and I add the name for the first child, then I add type, an icon, and the stats, and so on and so forth. And the nice thing about this is if the icon happens to be null, then I don't even save it. I don't actually do anything. I just omit this field altogether. Same thing with stats and scripts. If there are no scripts, I don't even add this section right here. There isn't going to be a section called scripts inside the file. For deserializing the data, it's fairly straightforward. I just get the child of type name, which is exactly what I saved, and I convert it to a string so it can be assigned as is. Same thing with all the other fields. Now to read and write the file, I have this segment right here, but let me just show you it in action. I'm gonna hit play. All the data still shows up, meaning it's working. And if I tab back to my file, notice it was 39 bytes in binary format, and it is now 79 bytes in ASCII, well, in text. But in this case, I get a lot more information to work with as a human being. I can actually see exactly what I'm modifying. Like here, I have an item, has a name, right here, type, and the stats, and I can modify it. Say, for example, I want this to be string 15. Just save the file as is, and now if I happen to tab back and comment out the part that does the writing, and just leave the part that deserializes, tab back to Unity, hit play, you'll notice this right here, strength is now 15. So I have the full ability to modify this file on the fly as I see fit, and yet it still gets saved in a fairly efficient manner. Remember, the original file was 714 bytes, if I remember correctly. This one is only 79. Of course, sometimes you might want to save it in binary format, so I decided to write both binary and text-based serialization for the data node. Here I have another segment that has the same exact code, except for the last argument it happens to pass true, which is what specifies that it's going to be in binary format. So now if I go back to the game and hit play, all the data will still show up. However, the data will be saved in binary format, 76 bytes. It's not as efficient as 39 that I had earlier with the stream, but in this case I'm saving all the names of all the fields, so it's more robust. And of course I can simply take this file, read it from its binary format, and then save it as text just by using basic code, which is actually the best of both worlds. But anyway, I know sometimes we as developers, we don't really have much of a budget when it comes to time, and we don't really have time to write all these functions for serializations. So just to recap what we started with this file, which is 714 bytes long. And here I went back to exactly all that. I'm not using the TNet for the optimized list. I'm just using a generic collection. I'm not using anything except adding the serializable. The only thing I'm going to be doing differently, and by the way, all the serialization functions are commented out now. The only thing I'm going to be doing differently is I'm going to use a custom serializer. I'm going to be using a reflection-based method that I wrote. Now this reflection method, it is basically designed to write out all the common types more efficiently, and if it encounters something like a list, then it's going to write it even more efficiently, and it's going to skip all the unnecessary information like assembly and whatnot. So anyhow, here I'm going to tab back to Unity, and I'm just going to hit play. As you can see, everything here is still showing up just fine, and if I tab back, it's going to go from this much data to only this much. So 714 down to 121. and I did not have to write any functions at all. It just works. Now, of course, when I say that I did not have to write any functions, I mean I as the final developer did not have to write any functions. So there's nothing in the player item itself that would serialize it. All I'm doing is just using the normal stuff, saying this class is serializable, and that's it. Nothing else. And yet I managed to optimize it. Now that's actually pretty convenient. All the hard stuff is actually done underneath, under the hood in this class. So if you look at it, you will see that I have all the common components coming out as IDs basically. Instead of writing out the long string saying like, oh, this is a Unity engine.quaternion, it will just write 11, and I will know exactly what kind of data is to follow. And of course I can optimize it further just by making a player item derived from binary serializable, which is an interface that is in TNet, and inside of it just has two functions, serialize and deserialize, which is what I was using before, if you might remember. So I'm just gonna uncomment it. These are the functions here, serialize and deserialize. Now if I tap back to Unity, it will compile. It will still work, but the amount of data saved is going to be a lot less, only 51 bytes. So as a developer who's strapped for time, I can just choose to go with the convenience method and not do anything and simply have it do everything for me. Or I can choose to override the serialization functions and just write my own custom serialization for those classes that actually need them. Classes that I know I'm going to be sending over the network frequently, for example. And by the way, everything you saw in this video is going to be a part of the next update for TNet. So if you have TNet, you're probably going to find it pretty useful. Well, anyhow, I think I've rambled long enough. Thanks for watching, guys, and have an awesome day.